Hello everyone, my name is Hari Zafri bin Muhammad Kamsani. Today I'm going to talk about the dispersal of marine invertebrate larvae. So what is marine invertebrate larvae? Marine invertebrate larvae are microscopic free-living development stages that differ greatly in form, habitat, and behavior from the adults. What is metamorphosis then? Metamorphosis is the rapid development, the transition that links the planktonic larva phase to the benthic juvenile or adult phase. What is the importance of larvae stage then? It is to provide dispersal and also the growth of the organisms. How the environmental cues influence the larva? Okay, biological cues such as microbiofilms can often essential for inducing the metamorphosis for certain invertebrates. The specific bacteria products such as lipopolysaccharide and extracellular vesicle can trigger metamorphosis. These are some examples that some organisms that have larval stages, such as Cnidarian, and also other examples such as crustaceans. What is ballast water? Ballast water is the fresh or salt water held in the ballast tank and cargo hold of ships. These ballast tanks can contain diverse planktonic and benthic organisms, including larvae and eggs, some able to withstand harsh tank conditions. Organisms inside ballast tank can travel in a long distance until ballast water were released at certain places, introducing invasive species to the area. One specific example of species that are mentioned in Wow Bear et al. Is the zebra mussel, which can cause major ecological and economic damage after transport by shipping. What is the ecological and economic impact, you wonder, or the ecological impact of the invasive species that can come from the ballast water is they can alter the community structure or can cause biodiversity loss. While the economic impact is the public health risks from pathogens and waterborne disease transported from the ballast water. What is biofouling? Biofouling is the unwanted accumulation of organisms and their products on some surfaces such as the surface of ships or aquaculture equipment. These are the main stages of biofouling, including conditioning film, microfouling, macrofouling, and also the mature community. Then how marine larvae contribute to biofouling? Biofilms can provide chemical and physical cues that can induce, inhibit, or sometimes they have no effect on larval settlement and metamorphosis. These larvae use these cues to choose habitats and successful settlement can lead to growth of the adult form. These are some impacts of biofouling on marine industries. On ships, it can increase frictional resistance. Mainly, they can cost more to for maintenance. On offshore, it can enhance corrosion, and in aquaculture, the biofouling on gear can cause reduce in growth and survival of farm bivalve and costly control actions. These are some impact on biodiversity, which include the artificial structure with heavy biofouling can alter the community composition in some area. Okay, moving on to the current environmental challenge. Now, the major challenge we have right now is the climate change, which can alter ocean temperature, chemistry, and also the circulation. Okay, move on to the physical circulation and transportation. It can the change of wind and stratification and also the currents can redirect laden or shorten larva transport. How about the physiology and behavior of the larva? Warming, acidification, low oxygen, and other stressors can influence growth, development rate, and also the habitat detection, which together determine mortality and dispersal distance. Now, the main issue is how ocean warming can affect the metamorphosis success. From the study of Ross et al. That I read, early development of invertebrates is vulnerable to acidification with reduced growth, size, and sometimes impaired metamorphosis. Additionally, for some calcifiers, low pH slows organogenesis and shell formation. In corals, the echinoderms, warming often hasten metamorphosis. How about the effect of changing ocean conditions to the spread of invasive marine organisms? Okay, can alter currents and temperature regimes, and we expect it to shift in species biography because this dispersal barriers and bacteria depend strongly on oceanography and larval traits. As climate envelopes or the temperature move, the currents also move. It can limited limited the spread may instead carry larvae into the newly suitable areas. Now, since we all use online shipping, so we also use the worldwide shipping, which can also um, okay, which which include the cargo ships that move huge volume of ballast water and also host most of the organism that can be invasive. These are some international concerns that regarding the ballast water management, which include the ballast water recognized as major marine pest vectors. International regulation are also being done to reduce the effect of the invasive species came from the ballast water or and also biofouling. These are some the current these are the current management of ballast water and biofouling is effective but still incomplete because it have been done but not everyone practice it. These are some of the limitation and challenges in reducing the number of invasion from those biofouling and ballast water. So some future direction and improvement are also suggested to help mitigate these problems, and some potential future solutions are also have been recorded in some papers. These are some rules that we need as marine scientists. We can improve the larval dispersal models. For government, they need to set and enforce standard and phase out high toxicity. For industries, they need to adopt and co-develop greener coatings. Okay, that's all from me. Thank you very much. These are the reference. Right. Thank you.